Everyone, welcome to Math 70. This lecture video is on section 2.8, which is parallel and perpendicular lines. All right. Okay, so parallel and perpendicular lines, thinking back to our representations, symbols, words, numbers, and pictures, it's mostly going to be symbols and pictures. We can, of course, think about representations with any of them, but this is mostly going to be symbols and pictures. The parallel lines are like railroad tracks. They are always the same distance apart. So if I were to draw this using my visual representation, I can just drop any line that I want on there. Here's a line. And if I want to make a parallel line, I just make sure that they are always the same distance apart. And they actually kind of look like railroad tracks here. They're never going to touch. They're always going to be the same distance. Now, this is this is going to be a short video, by the way. Thinking about lines as slope-intercept form, what I would like you to notice is that the slope of each line is the exact same. So the slope of parallel lines are equal. And how do I know how far apart they are? Well, I can look at the two y-intercepts. The distance between the y-intercepts tells you how far apart they are. It looks like pretty close. It looks like the slope here is about 1/2, right? If it goes over 2, it goes up 1. And that y-intercept looks like it's about 1, and this y-intercept looks like it's about 2.5. So I can write down the formulas for these two parallel lines. The upper one is y equals 1/2 x plus 2.5. And the lower one is y equals also 1/2 x, and now plus 1. And the slopes are the same. And that is how you figure out if two lines are parallel. And that's how you draw two parallel lines that might go through different points. Okay, that covers parallel lines. Now let's talk about perpendicular lines. Perpendicular lines cross at right angles. So again, let's start with the graphical representation. Here's one of my lines. And if I have a perpendicular line, it's got to cross at a right angle. So if I think about a nice right angle right there, there's my little right angle. We know we make it a right angle if we can draw a little square and it fits right where those lines meet. So if this is my line number 1, y equals mx plus b, then this is my perpendicular. Finding out the formula for a perpendicular line is much more challenging, to be honest, than for a parallel line. Parallel lines, you just keep the slope and you move the y-intercept up or down. Perpendicular lines, you have to do a little bit more work. So let's use, for example, this line here, which y equals mx plus b. If you look a little more closely, you see that the y-intercept is 1. And the slope here is 1/2. So y equals 1/2 x plus 1. Now the perpendicular line, which crosses at a right angle, that has a slope of -2. X goes over 1, y goes down 2. So this is my original and my perpendicular. I'm going to abbreviate that to perp. It still has the form y equals mx plus b, but this time the slope is -2. So we figure out the slope first. And 1/2 to -2 is not a coincidence. The slope of a perpendicular line will be opposite and reciprocal. Opposite means change the sign. Reciprocal means flip upside down. One half, change the sign, makes it a negative, flip it upside down, make it a 2 over 1, which we write as -2. 1/2 x plus 1 versus -2x plus some y-intercept. If my perpendicular line, or if my original line was -3/5 x, let's say plus 8 or something, then my perpendicular will be flip it upside down, or sorry, let's start with change the sign, so make it positive, and then flip it upside down. 5/3 x plus some y-intercept. So the slope is not as easy as it is the exact same, the way it is for parallel lines, but it's still a fairly simple rule. You change the sign. If it was positive, you make it negative, and then you flip it upside down. 1/2 flips to 2, 3/5 flips to 5/3, and then you also change the sign. Finding the y-intercept is the part that's a little more difficult, because we have lots of perpendicular lines. And the y-intercepts don't always follow a nice simple rule. So I'm going to give you, I'll show you again using what I had before. So here's our original line, which was y equals 1/2 x plus 1. And here's one of my perpendicular lines, like that. And you can see that the y-intercept is going to be way up here off the page somewhere. And here's another of my perpendicular lines. And I got lucky here, the y-intercept is really easy to see. And here's another of my perpendicular lines. Let's see if I can draw this. And this time the y-intercept's going to be way down there. So finding the y-intercept of a perpendicular line is not as simple as just saying how much above or below is that line. what you do is you have to figure out where these lines meet and then backtrack to the y-intercept. So I'll show you one example of that. But to be honest, the more important piece to draw from this is understanding how the slopes of the lines are either the exact same for parallel lines or the opposite and reciprocal for perpendicular lines. So let's take y equals 1/2 x plus 1. And we're going to draw, let's draw this line here. That's perpendicular because it makes a little square. And I can see the slope of this is -2. So y equals 1/2 x plus 1. This is y equals -2x, but I don't know the y-intercept yet. But I can see right there, it's got a point in common. And as soon as you have a coordinate point, you can figure out your y-intercept because I know the point 2, 2 is on the perpendicular line. So I build my little table, 2, 2, and I know that y equals 2, sorry, try one more time. I know that y equals 2 when x equals 2, and I add that y-intercept. So 2 equals -4 plus b, and I add 4 to both sides. And I see that b equals 6. So the formula for this perpendicular line is y equals -2x plus 6. All right, I wanted to make this video because it is material from the book, but I'm going to remove the 2.8 assignment from your list of assignments. The takeaway that I want you to have from perpendicular and parallel lines is that for parallel lines, the slopes are equal. And for perpendicular lines, the slope of a perpendicular line is opposite and reciprocal. Okay, thanks for watching.